We really enjoy answering subscribers' questions. Sometimes, though, the comments are not enough and we need a video, and such is the case today. Because we've been asked by one subscriber in response to the ASRock M.2 16 quad card about an X570 chipset. So of the two we've been asked about, that's going to be our first one. Let's take a look at the comment. And this is from Vivian KV. I'm planning to build my workstation. Would like you to please take a look at my build list. That's been reworded from the original message, but let's take a look at what we've got, because two things we want to focus on, and the title of this video is going to be about the motherboard and the GPU. Okay, so this video is the Asus X570 ROG Crosshair VIII Dark Hero and the RTX A5000. That's a lot of machine on a really tight box. My first suggestion is, as always, change one thing changes everything. And even though Vim defines this as a workstation, we've identified four classes of machines. Number one, an entry-level 10-core. Number two, a secondary, which is 16-core, which is what this is at. Number three would be a high-end desktop, and that's on the TRX 40, such as the machine that we do most of the testing on, that we've tested heat sinks on, that we've tested the three last quad cards on, the Asus, the Gigabyte, and now the ASRock. And then, of course, the fourth level would be the WRX80. That's a workstation where you've got to have lots of resources. And right now, everything about all the stuff that we talk about is about PCI Express resources. That's what we're focused on. So I want to go through this and let's itemize, because, again, change one thing changes everything. So to reiterate, we've got an Asus X570 ROG Crosshair Hero 8. Okay, there's three places we're going to go look with Asus so that we can discover how that resource allocation is laid out. Number two, he shows two RTX A5000. Now, I don't know if that's the starting point or the end point. And I gather from what he is telling us, that may be the end point, because he mentions about the memory, the G.SKILL TRIDENT, which could be Samsung B-Die. We'd have to check and verify. For the storage, he's got a Samsung 980 Pro, 2 terabyte, good place to be. That is a PCI Express 4.0 second generation drive. Power supply, I believe that's different from the one he first listed. RM1000X. I'd have to verify who makes that, because my suggestion on a power supply would be something from Superflower. They make OEM power supplies. We'd have to check it out. Case, great case. Fractal design Meshify 2. Cases like that are more about form over function. Y'all know where I stand on that. We're all about function over form. And we've still got some stuff that we're going to do later in another video about doing a rack mount. A computer like this would classify for a rack mount, because we're looking at something that'll fit in 4. The problem we get into with rack mounts, it's got to be ATX. This is an ATX motherboard. He didn't ask that, but that's a side note. So back to his specs. A few questions. Number one, the cooler. Do you think I need more coolers? Well, that depends on the case layout. My first suggestion about the case, kind of like this, we use the Noctua industrial fans. The advantage of that, we can put those fans down where we need them, but as one subscriber commented, when you hear those fans rev up, that's kind of like the canary in the coal mine. When you hear that rev up, something's going on, something's got a problem, needs to be dealt with. Now, this is a workstation for rendering, and let's go to the next step. So let's think again about those fans. Any fans that you have that are 3-pin fans, you're going to want to change those out to 4-pin fans. Why is that? Well, a 3-pin fan is off and on, whereas a 4-pin fan, you can adjust it. And I'm not talking just off, on like the ASRock, or in the middle where it's at half, but you can vary that with pulse wave modulation, which is another separate video. But anyway, that's how your CPU fan is set. It's a 4-pin fan, so you can vary that speed according to what you need to keep it cool. Now, depending on the cooler, let's look at that. The cooler is a Noctua, and if I remember correctly, I think that is the Chromax, which are the black ones. Anyway, the point of it being, it comes with one CPU fan. My suggestion would be to put a second CPU fan. Now, going to make a little more noise, going to do a little bit of good on cooling, not a lot, but every little bit helps. And I don't think it's going to be a noise, it's going to be objectionable. And with the cooler from Noctua, it will include the bracket mount, but you'll have to get the second fan to do that separate fan. So to reiterate, 2 fans on the CPU cooler. Whatever case fans you've got, you can work with what they are, but I would change them out with 4-pin fans. And my first choice for control would be from the motherboard. The second choice would be with a controller, if you've got a case and accommodate the controls, so that you can then use 1 header, 2 fans, 3 fans, or 4 fans, which another video that we might get into some other time. We talked about that or hinted on that with heat sinks, but didn't really get into it because, well, another video. Let's get back to the specs. I want to stay focused on this. Okay, I want to touch a bit on the memory. Based on the memory of 64 gigs, G.SKILL TRIDENT, as I said, to reiterate that, that's probably Samsung B-Die. What you have not heard a whole lot yet, but you will be hearing more of in the future, is the Adobe After Effects multi-frame rendering CPU optimization formula. Two things to remember as it relates to the CPU, the RAM, and the video card. Okay, number one, CPU cores times 4 equals RAM. On this machine, which is the Gigabyte TRX 40 Designare, where we have two 16-lane slots and two 8-lane slots, what we have in here is 256 gigs of RAM, which is overkill, but the purpose was to see if we could fill up the board, see if it could run it, see if it could boot it, and it does. Okay, on this, for that formula, number one, you got 16 cores. 16 times 4 is 64 gigs. Perfect. Now, spot on for number two, 16 cores equals a video RAM. So if you got 16 CPU cores, you need a video card with 16 gigs of video RAM. And if you're looking at an A5000, that's 24 gigs. So I think you're good to go with the CPU, with the RAM, and also with the GPU, because this is a GPU that's a workstation class, but you have to keep in mind of a consumer video card versus a workstation class video card. It's going to be 2 slots wide. It's blower style. It has lower power requirements. It's also easier to do the bridge. And I had another subscriber comment about that bridge. As we've looked at and discussed bridges, because again, we have two 16-lane slots. If we had 2 GPUs in here that reach 2 slots wide, we would have a 4-slot bridge. Okay, I mentioned that because a subscriber commented you can take one of these RTX 3090 bridges and said it will work on the A5000. I don't know that. I haven't seen that written down. But if that's the fact, you can check it out, travel at your own risk. Because typically, according to NVIDIA, the bridges for 2 of those are either 2 slots or 3 slots wide. And 2 slots wide would put us in an odd precarious position, which would put us for a 16-lane slot and an 8-lane slot. That would be 2 slots wide. 3 slots wide would put us in another spot that we don't have. So 2 GPUs side by side, one's in a 16-lane slot, one puts in an 8-lane slot. And again, this is on the TRX 40. So on the X570, now I want to go into the motherboard situation, show you how those resources play out. Because again, change one thing changes everything. But before I do, let's go down through the specs and get through some more of that. So hold that and keep that in the back of your mind. Okay, so we've addressed the coolers, the motherboard. I'm going to get to, do you have any recommendations for RAM and motherboard, multiple GPUs? Okay, multiple GPUs, is it worth it? That's the big $64 question. Hold that thought, I'll come back to it. Is NVLink worth it? And do you need a special X570 motherboard for NVLink? A lot of big questions that need some answers. And that's why we like to demonstrate with this machine, because you're going to have a problem with resource allocation. Like I said in the beginning, it's all about PCI Express resource allocation. And we're going to have an issue with any X570 motherboard making that kind of stuff work with multiple GPUs. Now, we've got another subscriber that I've been talking to, and he's the first yet who's looking at some software, Redshift, for those of you that are aware of it. And I don't believe Redshift was mentioned by, no, I don't see Redshift mentioned. But Redshift is one application that can use 8 GPUs. Wow. I'll put a link up in the description so you can check that out. But if you're going to use multiple GPUs like 8, that's one application that can take advantage of it. But that's one application that even though they can take advantage of it, you got to have the motherboard with the resources, which is back to a workstation, which is back to a WRX80. So if you want to do multiple GPUs, you need to look at the software. And I like to look at those and itemize because, again, Adobe has the best formula for laying all this stuff out. But a lot of other vendors are not quite as up-to-date as Adobe is. And even though Adobe has put that information out, they themselves are still not fully utilizing it. This Adobe After Effects multi-frame rendering CPU optimization formula that when we did the video was supposed to be out in May, and here we are October, and it's still not there. But when it does, it's going to be a big deal, so keep that in mind. So as we relate this to the machine he wants to build, multiple GPUs, is it worth it? Number one, can your software take advantage of it? All software takes advantage of 1 GPU. Some can take advantage of 2. but Redshift is the only one I've seen anything in print that says it can take advantage of 8. So if you want to do one GPU, go for the gold. If you think you're going to upgrade to 2 GPUs, my suggestion, I would want the resources where they're both in 2 16-lane slots. And the other question about the next X570 chipset is going to involve some of this again. So we'll go through this again. And I've decided every time you guys ask about a motherboard, instead of just making a comment on it, we need to do a video, because we want to try to help as many subscribers and viewers as possible. And if we do a video, and if we put it up where people can find it, we're going to help more people. This is all about PCI Express resources. You're going to hear me saying that like a broken record, but it's just a fact. Vendors obfuscate that information. It's there, but what we're going to do is we're going to extrapolate. So let's go a step further. Let's go look at the motherboard, but hold that thought. Okay, so we've identified about multi-GPUs. We're talking about NVLink that can be 2 slots, 3 slots, or possibly 4 slots wide, but I don't have a confirmation on that. All I have is one subscriber saying it works. Do you need a special X570 motherboard for NVLink? Part of the same question. And then what should I keep in mind if I decide to get multiple 2 RTX A5000s? How many PCI lanes do I need on an X570 motherboard? See, it comes right back to PCI Express, PCI resource allocation. So what we're going to do, we're going to now look at the motherboard. 3 places we're going to look. This is kind of different than trying to look for Thunderbolt, because I won't get into that, but it's just a separate thing. There's other information I have to look at for Thunderbolt. But as it relates to this question about the X570 chipset, let's first go look at the motherboard. Then we're going to go look at the technical specs. Then we're going to look at the manual, and we're going to compare those 3 and see how that's laid out. All motherboards will have something about PCI Express resource allocation on a chart. We just have to find it. Okay, the Asus Crosshair VIII Dark Hero. So the first thing we'll notice here, we got 3 slots. The primary, the secondary, and the third or the tertiary. Next thing we want to do is take a look at the technical specs. I'm not interested in multi-GPU support. That's irrelevant. What we want to know is the expansion slots. Okay, with an AMD Ryzen 5000, because we're 16 cores, says here we have 2 PCI Express 4.0 by 16 slots. Mechanically. Electrically, it's 1 by 16 or dual by 8. And those are direct to the CPU. The third slot is 1 PCI Express 4.0 by 16, and that's through the chipset. Okay, that's 2 places we looked. Now the third place is, let's go take a look at the manual and confirm that. Usually motherboard manuals will have a layout diagram, but then there will be a chart with specificity on PCI slots. So we're going to look at those 2 things in that one manual, and this will make the third place. We'll go to Support, Manuals and Documents. We'll download, and the first thing I want to do is identify these slots. PCI Express by 16_1, PCI Express by 16_2, and PCI Express by 16_3. Okay, all 3 of those mechanically are by 16. The problem is, how are they allocated electrically? One more place to look. Okay, here we are on page 22 in the PDF manual that can be downloaded from Asus. Recommended Vga configuration. What we're looking at is the slot and lane assignment. Number 1, 2, and 3. PCI Express 4.0 by 16_1, single by 16, _2, dual by 8, which means that's a shared resource as long as you use 1 slot by 16. But if you use both slots, each is by 8 electrically. And on number 3, that's a by 4 slot, and that number 3 is through the chipset. So we've confirmed those resources. If you're going to use that motherboard with that chipset, you've got 2 8-lane slots, and you're going to put an RTX A5000 on that. So my suggestion is a choice. So that's the state of PCI Express resource allocation on this particular motherboard. So to reiterate, let's take a look at the TRX 40, and I'll show you. That's why this is such a great example. Okay, on this motherboard, we have as we contrast it with that one, we have 2 16-lane slots and 2 8-lane slots. We have 4 slots. This motherboard has 3 slots. This motherboard has 1 16-lane slot that becomes 2 8-lane slots. Okay, on this motherboard, I have 2 16-lane slots and 2 8-lane slots. Those are dedicated resources. On this motherboard with the X570, those are shared resources. You don't want shared resources if you're going to put in an RTX A5000. If you want 2 dedicated 16-lane slots, you're either going to have to, you got 2 choices. Use 1 GPU. If you're confirmed and convinced, you're going to do 2 GPUs, and that's what you're going to upgrade to. then you need to upgrade also the motherboard and the CPU, which means you're looking at a high-end desktop, which means you're on the TRX 40, so that you get those 2 dedicated 16-lane slots. And in this case with these, we would have to bridge 4 slots, which would be an RTX 3090 bridge that I do not have confirmed works, but a subscriber says it will work. Otherwise, I'm in the same boat. I have a 16-lane slot and an 8-lane slot, and if I were to bridge from here, even though these are dedicated, one GPU is only getting 8 lanes. Now, is that a big deal? Okay, you're not going to flood the bus, and all this PCI Express resource allocation is not about the GPU. However, when you're rendering, that's the end goal. Right now, PCI Express 4.0, PCI Express 5.0, it's all about the M.2 NVMe drives and how the speed has increased on those dramatically. Faster they get, the hotter they get. So because what you want to do is rendering, you need the resources. I can't drive that home enough. And as we go back through these questions, how many PCI Express lanes do I need? My suggestion and my preference, even though it's about to reiterate the M.2 NVMe, if you're going to be rendering and this is your thing and you're going to work with those 2 cards together, you want 2 dedicated 16-lane slots. So you've got to go to a TRX 40 motherboard. It is what it is. I've got some more information that he shared that I think may have some applications that I want to share with you. Vibin then came back with another message. Thank you so much for your information helping people to build up their PC workstation. Your information is extremely helpful. Thanks a lot. I'm an animator. Most of my jobs are animation and compositing, and I am mostly using Blender, Maya, Arnold, After Effects, and Nuke. Okay, the one that gives us the best formula is Adobe After Effects that we've outlined. Unreal Engine is a great idea. It probably is the easiest on resources. But again, as the statement always goes with Adobe, they'll take all the resources you can throw at it. And when we first saw the information about Adobe After Effects and what AMD said, how that worked on the Threadripper Pro WRX 80, that was the one application that benefited the most from a workstation. Kind of blew my mind. I didn't know what I was looking at then, but I have a better understanding and grasp on it now. Wow. So we can come at this from 2 directions. 1, the hardware. 2, the software, because it's all about the results, whether you're rendering audio or rendering video. And the aspect of the software is about how many GPUs each one of these can use. And Redshift is the only one I'm aware of that can use up to 8 GPUs, based on the information I've seen so far. So if you guys are aware of an application that can use more than 2 GPUs, I'm all ears, because I know some of you have been talking about putting 4 GPUs, and that's why, as we've gone through this with the WRX 80, which motherboard to use based on what you're doing. Multiple GPUs, only one choice. But if Thunderbolt is your choice, there's only one choice of motherboards for that, but that's a separate video. Got some more that Vidman added. He then added another message. The Ryzen 5950 24 PCI lanes 4.0 equals 16 GPU, 4 for the PCI NVMe, 4 PCI chipset downlink. Will that use 2 RTX A5000 with chipset line X570 on the Asus Dark Hero split the PCI 4.0 slots to 2 8x8? Will this affect performance? I kind of gather that that's not his first language. So, 16 cores on the CPU, what you want to focus on, even though there's 24 PCI Express lanes, you've got to have, or you should have, if you're going to use an RTX A5000, 16 dedicated lanes per GPU. So 16 and 16 is 32. You look at the math, 24 ain't going to work. And for the 4 PCI Express lanes that are allocated for the M.2 NVMe drive, let's go back and look at the specs. According to what I see on this manual, this looks like we can allocate 1 M.2 NVMe drive. So yes, that's 4 PCI Express lanes. And it can do the 3 links, of course, 2280 being the standard. I don't see one of those DIMM sockets on this board, but we'll do a quick check, see what else we can find. Here's a note I didn't see a while ago. Please refer to the following tables for the recommended Vga Configuration and Hyper M.2. So you could put a quad card on this, but it's going to be in that first 16-lane slot, which means you're only going to be able to access, well, let's see what the chart says. Okay, Hyper M.2 by 16 series card configuration. Well, that's news. That says PCI Express 3.0 by 16_1. I think that should say PCI Express 4.0. So I really think that's a typo. But anyway, they talk about using 4, yes, but it does not show how you're going to use a GPU. And it shows if you put it in the second slot, you're only going to get 2 because 4 and 4 is 8. I don't want to get too much in the weeds on this, but I want to mention this because the question will come up about the quad cards. On this particular machine, no, I wouldn't put a quad card because it's about the RTX A5000. It's interesting how Asus will show you how one thing will work, but does not show you how both things will work. So if you want to do that, yeah, you can do that. But you want to do that? Well, yeah, you can do that. But you want to do both those? No, you can't do that. Obfuscate. Anyway, the information is there. It shows what can be done, but it's not real clear on what cannot be done. And that's the thing that we like to extrapolate and bring out. It's all about PCI Express resources. So I think the takeaway from this, when we first looked at the X570 chipset, and we have a video up about this, I was gung-ho, but we looked at the chipset based on the specs. And the way AMD had that spec laid out was beautiful, it's phenomenal, glorious. But the way the vendors have implemented it, I would like to sit down with somebody and say, okay, we're going to design a motherboard. We have a chipset. Here's what we can do. Is there some way we can arrange these resources so it makes a whole lot more sense? Because, and of course I'm asking the impossible, you cannot allocate 2 16-lane slots when you've only got 24 lanes to work with. It just square peg in a round hole, it ain't going to fit. But if there's some other way to reallocate some of those other resources. There is one Asus motherboard that has one dedicated 16-lane slot, but that second 16-lane slot is an 8-lane slot, and it shares resources, if I remember correctly, with the other slot. Now, I've looked at all, the only motherboard that I've looked at all of in the X570 was Gigabyte, and Gigabyte does not have one X570 that has one 16-lane slot that's dedicated. They're all shared. And there is one Asus, but I don't remember which one it is off the top of my head. But to reiterate, when you go to the next slot, because it's shared, it's still, you're kind of SOL. But I don't mind going through this because I like to explain this because it's about, you know, what can I do? Let's look at it, extrapolate. Our goal is, number one, keep it simple, and number two, make it work. Let's go back. Okay, here's a good example. I didn't see this on the board layout a while ago. This is on page 27. I want to blow this up big so we can see it. There are actually 2 M.2 sockets on this motherboard. M.2_1 and M.2_2. Okay, that tells me that the primary is to the CPU, which will be the fastest. So let's get down here in the nitty-gritty. M.2_1, PCI Express 4.0x4. Okay, that's to the CPU. And here we are. For the AMD X570, M.2_2, also PCI Express 4, but it's through the chipset. So your fastest will be number 1, which is right next to your GPU. And then the second one, which is through the chipset, will be a little bit slower. Your second fastest would be if you could have put in like a dual adapter, but you lose performance on your GPU. So to find out how this all worked, one, I wanted to check the motherboard out, had to know what the chipset motherboard is. So I went and looked to visually inspect it and see the slots. Number 2, I went to the technical specs, did a quick scan of that. Number 3, then I went to the manual. And then in the manual, the first thing I did is I wanted to look at the motherboard layout. Sometimes there's a diagram layout that'll show electrically how everything works. Some manuals have them, some don't. Asus used to be the best, but it's been hit or miss with who has it and who doesn't. But then after we did the slot and lane assignment, because my curiosity was piqued on how that was allocated, I then did a search on M.2, and that's when I saw, which I didn't see before, the other slot for an M.2 drive. So you've got a 16-lane slot, or you've got 2 8-lane slots, and then you've got a 4-lane slot, and then you've got 2 M.2 sockets, which is each 4 lanes. So 4, 8. Yeah, see, there's just, I've been trying to figure out if there's some way that could have been, that's a tough sell on the X570. The goal of a vendor is to get you to buy a new computer more often so that you build less so you'll build more often. Our goal, keep it simple, make it work, is for you to build a little bit better so it lasts a little bit longer so you don't build as often. And we got a lot of people coming out of the woodwork that have built 10-year-old machines that are now looking and saying, wow. Yeah, we got lots of wow. We're getting ready to take another wow leap with PCI Express 5. And saw a press release on that AMD next year, 2022, is going to support PCI Express 5.0. Okay. As excited as I am about PCI Express 5, the PCI Express 6 specs have been finalized. That's going to be in the works. So I say that because PCI Express 5 may be short-lived. Number one, you're doing rendering. So you got to consider the end result. If you can live with one GPU, you're good to go on the platform. If you've already bought the motherboard, enjoy. If you have not, and you think you want to be able to upgrade, the only upgrade path you have is on the TRX 40. And that's why we've been advocating and showing and demonstrating all these tests on the TRX 40. As great as it is, it has some built-in limitations, but we understand those limitations. It gets over the high-end desktop of what you have when you build an entry-level machine with 10 cores, a secondary level machine like this with 16 cores. When you build a high-end desktop, you have more room to grow, whether it's the CPU, whether it's the GPUs, or whether it's one GPU and a quad card like we've demonstrated, or a quad card and a dual M.2 adapter. So I hope this helps. This is BuildOrBuy. My name's Gil Boyd. I want to thank you for joining us. We're on to the next video. We're out.